So we've been working in sections 12.1, 12.2, and we have gotten to, I believe, example 6. Does that sound right to you guys? Excellent. So let's take a look for that one. All right. It says to consider a parallelogram along with one of its diagonals. So I don't have my diagonal drawn in. Let me put it in there. That's terrible. Let me try that again. That's a little bit better. Okay, so here's my parallelogram with one of its diagonals. It says to use the definition of a parallelogram and the angle-side angle, ASA, congruence property for triangles to show that the opposite sides of a parallelogram are congruent. All right, so let's start with, what do you remember, or what can we look for if we're not remembering? What is my definition of a parallelogram? Excellent. The opposite sides are parallel. So if you take this side on the top, we'll mark it with double arrows, and it would be parallel to the side on the bottom. So CD is parallel to AB, and AD is parallel to BC. Notice it doesn't say anything about being equal length. It only says details about being parallel. Our goal is to prove, to show, to verify that they are in fact also congruent lengths. Okay, now we had some features about parallel lines that showed up on your exam, and back in chapter 11, some facts about parallel lines in terms of their angles. For instance, if I take the diagonal that I've got here and I were to sort of extend it like this, it intersects parallel lines, right? In particular, what can you tell me about this angle and this angle because of the lines? They're congruent. Do you remember what they're called? Those two? Close. Alternate interior. Yeah, they're alternate interior angles. So if you want, you can label them with numbers just so that we can call them, angle 1 and angle 2. It'll be easier to write it up here in a minute. If you want to call them with their letter names, that's fine as well. So that's important information. We've got a set of congruent angles. We also have one congruent side that we know for sure is congruent. Yeah, the one they share, right? The diagonal I drew in. So side BD is congruent to itself. Now, there's actually another pair of congruent angles here that I haven't marked. Do you guys see where they are? I saw some nodding heads. Where are they? So right here and right here. Yeah, for the same reason, they're alternate interior as well. They're by comparison to the the lines here and here, though, right? That's the lines that we're using. So yeah, those are also congruent. So how about we call them 3 and 4, just so I can reference them a little bit easier. All right, so if that's the case, if I have these congruent angles, I've marked them with colors here. Angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, and side BD is congruent to side BD. Now what? What does that tell me? Angle side angle, what does angle side angle tell me though? The triangles, right. I've got congruent triangles by angle side angle, right? And if I have congruent triangles, then that means that the sides that are in comparison for those triangles are also congruent. Namely, the side at the top, CD, would be congruent to the side at the bottom, AB, and the side on the left, AD, would be congruent to the side on the right, BC. So everybody kind of see what's going on with those. Okay, we're going to write it out now. So we have 3 sets of information that we need to prove. The angle, side angle, we have the angle, we have a side, we have another angle. So whatever order it is you want to do that in, I'll do the side first because that's actually what we drew first. BD is congruent to BD. And why did we know that that was true? I think Allison's the one who said it. What do you have? They're the same, right? And that actually has a name. It's called the reflexive property. So think about like a reflection, right, in a mirror. Reflexive, that's the word we've got there. If you wrote down same line, I would be okay with that. It's not going to hurt you. Okay, this is the name for this. We also have some angles, and I named them with numbers because it's easier. Angle 1 is congruent to angle 2. And we talked about the fact that that's because they're alternate interior angles for which parallel sides? Angle 1 and angle 2, they're purple ones. They're alternate interior angles for which parallel sides? The horizontal ones, the top and bottom, yeah. They're alternate interior angles for AB and CD that are parallel. I think I'll write it that way. AD or AB parallel to CD. And then angle 3 is congruent to angle 4. They're also alternate interior. But for which sides? Which sides are they actually along in terms of parallel lines? DA and CB. Okay, and then, well, angle side angle is the reason. We actually have congruent triangles, right? So we need to be careful that we list them correctly. What triangles are congruent here? I'll start with side A, and then B, and then D. Which angle is congruent to angle A? C. So I got to list it first. Which angle is congruent to angle B in the lower triangle? Angle, which one? Angle D in the upper triangle, so CD. Yeah. And then which angle is congruent to angle D in the lower or left triangle? Angle B in the upper or the right triangle. So these are my congruent triangles, and this is true by angle side angle. All right, that's how I know this. Angle side angle. So now what? Why did I need to use angle side angle? What is my whole goal here again? Did you already forget? What are we trying to prove? I underlined or highlighted in yellow. The opposite sides, right? The opposite sides. So I know that AB is congruent to CD and AD is congruent to CB. Why? Why is that true? Okay, you're right. So if I can prove angle side angle, which we did, then we know the corresponding pieces are congruent, right? And we have an abbreviation for that. Do you guys remember it? I told you about it. We haven't used it yet, like the abbreviation. It's okay. Yeah, that's right. CPCTC. It's got a lot of C's. Corresponding parts of congruent triangles are congruent. So we have the opposite sides congruent, just like we were asked to do. All right, the one other thing that we're going to take a look at in this sections 12.1, 12.2, I have given you in the form of a handout. Okay? This handout is all about quadrilaterals. It has different quadrilaterals. We've actually talked about all these quadrilaterals. Yep, that's true, every single one of them. Trapezoid, isosceles trapezoid, parallelogram, rectangle, kite, rhombus, and square. There's a definition for each one of them and a picture, or a couple of pictures in some case, in one case, the kite. And then there's some relevant theorems. So basically, everything that's on the right-hand side of here is something that can be proven. In fact, we've just proved one of them. On parallelogram, we proved the parallelogram number 4. It's a quadrilateral in which, no, that's not the one we did. Totally lied. Where was it? There it is. Parallelogram. I was on the wrong box. Parallelogram. We actually proved number 1 on parallelogram. Opposite sides are congruent. All right? I believe in either your homework or your group work, you're going to prove number 2 on parallelogram. Opposite angles are congruent. The argument is very, very similar to this one. You're doing some triangles and you're showing the angles work out to being the way that you expect them to be as well. So all of these related theorems are things that you could be asked to justify why they're true. And almost all of them come back to some kind of an argument about triangles. Okay? So that's it for section 12.1, 12.2.